All right. Thanks, everybody, for joining. Really excited today to talk about network infrastructure automation with our friends over at Workday. Joining me today is going to be Devarshi Shah, who's on the product management team of our Consul ecosystem, and Daniele Vizzola from Workday, who's going to talk about how they're using Consul-Terraform-Sync to achieve network infrastructure automation at Workday. Before we dive into it, just a couple of housekeeping items. This session is being recorded, so we will be making that available at the end of this session, typically within 1 to 2 days. Throughout, feel free to drop your questions into the chat. We'll be answering them both throughout and at the end as we have time. And in order to get us started, I'm just going to kick us off with a quick overview of network infrastructure automation. So one of the reasons that we talk about this, and if you've seen some of our previous talks, is really the challenge we're hearing from customers is that they're experiencing this accumulation of tickets. So where they're having a lot of network operators focus a lot on these slow manual processes, and they're not being able to move as quickly as some developers would like. So where they want to be able to roll out new versions of applications in a quicker manner, attributing more to like a true CI/CD workflow, and the network becomes a little bit of a bottleneck because it's just overwhelmed by manual requests. As a result, we see this kind of like increased costs from having a lack of optimized network infrastructure. So really what we're looking for ways is how can we improve that efficiency and be able to use that infrastructure to the fullest extent. But we're seeing some increased risk. There's a higher chance of network outages from misconfigurations. As I have more services, I'm more and more reliant on people to key things correctly, make sure that they open up the right ports, and that I'm not running into any major concerns. So just to give an idea of like kind of how broad this is, we came up with this kind of concept to talk a little bit about the day two application scaling workflow. So what does it look like after an application gets deployed? So I have a developer who reaches out to a server admin, says, I need a new server for my workload. I want to deploy it. Network admin says, OK, great. We got to make sure that's assigned a new IP address. But if they didn't fill out all the information, I might need a new ticket. From here, maybe I need to register it with the appropriate load balancers. I need to check to make sure those workloads are healthy, that they're receiving all the right information. And again, I got to check, do I need another ticket? So you see this kind of process where basically they keep going into this, the more and more granular controls I get, where I have to worry about my switches. I have to make sure that they're all configured correctly. I have to make sure my ACL rules are in place. Then each time I have to double check to make sure I don't have to file a new ticket because I forgot to do one of these processes. This is very extensive, and if you look, it's very backloaded in terms of what the network admins and the security ops teams really have to be concerned with to make sure that their traffic is properly being done. So each of these times, if I'm filing these tickets, this is slowing down my process, and it doesn't really help me achieve that agility that I want to have in more like cloud-based environments. And some of the things that we've heard from various customers is that the challenge of adopting automation isn't that there's a lack of desire. It's that there's a challenge with the skill gap. There's challenge with integrations for different tools and different devices that people are using. And there's just not a model in place where they don't have this kind of operational model ready to go. And so we at HashiCorp, we basically looked at it and said, how do we want to address this for modern enterprises? And the idea of like automated workflows, and that the shift to dynamic infrastructure really forces organizations to reconsider all aspects of the business, including the network, and really trying to think about how do I overhaul my existing implementations and look to automate key processes so that I can move a little bit faster and deliver on what cloud is trying to promise me. And that's where we came up with this concept of network infrastructure automation. So when you hear us talk about this term, this is what we're talking about, the reduction in manual ticketing processes, the improvement of efficiency. And there's a few different ways that you can achieve that. And one of the ways we're going to talk about today is Consul-Terraform-Sync. So there's 3 different kind of varieties that we offer at HashiCorp to achieve this solution. Terraform is great from a day 0 or day 1 provisioning standpoint. If you look at the ecosystem, this is what we built Consul-Terraform-Sync on top of. This is going to still require some operator intervention, but it's a better workflow, and it's getting them used to the idea of doing things as code. From Consul-Terraform-Sync, the tool we're going to talk about today, this new integration enables Consul to deploy Terraform into environments, and it leverages the providers to automate tasks. So this is a really powerful tool. We're really excited to talk more about it. The other piece is that there are some workflows that maybe they don't need to totally overhaul things, but they're looking for a way to improve some efficiencies. We work actively with a number of our partners to create some dedicated networking integrations that can help with day two automation. So Terraform is a fairly standard use case. We know it's going to provide a single centralized workflow. It's going to allow me to be able to use our providers to provision and manage some of that infrastructure. Really, this is about like, how do I get started and how do I do it in a more efficient way, especially if I had to reproduce my environment in different areas. From a networking integration standpoint, we have integrations with Cisco, F5, and A10. These require fewer changes for operators because it's all part of the same workflow. And so they no longer have to run into the circumstance where they're trying to learn an entirely different tool. It's just a way that we can integrate better into these systems. And the one we're really excited to talk about today is Consul-Terraform-Sync. This is going to help you automate those manual tasks. And as a surprise, we actually are launching Consul-Terraform-Sync is generally available starting today. You should be able to access it later this afternoon on our site. We're very, very excited about this. We had some great partnerships with some different folks and been working with customers like Daniele over at Workday to really improve this process. And so before we dive into that portion of the presentation, I just quickly want to hand it to Devarshi to talk a little bit about Consul-Terraform-Sync and the features that are now going to be available. So Devarshi?
Thank you, Peter. So the concept of Consul-Terraform-Sync is pretty simple, as you saw on the previous slide. It's essentially allowing you to enable a publisher-subscriber paradigm where essentially you as a network operator or an operator of the downstream infrastructure can subscribe to Consul services, and based on those services, you can have dedicated runbook automation run, which is essentially through Terraform. So the architecture and the workflow is pretty simple with Consul-Terraform-Sync. I'll go into some of the details of Consul-Terraform-Sync and introduce some important constructs that we've introduced to Consul-Terraform-Sync in order to achieve that particular workflow. So the first and the most important construct that we've introduced is the construct of the network driver, which in our case, in GA is Terraform open source. And what this allows you to do is it allows you to specify that, hey, I want to use Terraform open source as the underlying driver for infrastructure automation. It allows you to specify the properties, which could be, I want to define a certain kind of backend, I want to define a certain kind of logging path, as well as the set of providers needed for driving that underlying automation. And what Consul-Terraform-Sync will essentially do is, if you don't have the right version of Terraform, it will go ahead and download that for you. It'll go ahead and download the right set of providers for you and configure the right backend to be used for Consul-Terraform-Sync. And if you have the right environment variables, it's essentially going to be building on top of that. As a part of Consul-Terraform-Sync, if you can go back one slide, Peter. Thank you. The supported backends right now are Azure RM, Consul, COS, GCS, Kubernetes, and S3, along with local as well. And by default, your supported backend or default backend for Consul-Terraform-Sync is going to be Consul KB. The second and the most important construct that we've enabled through Consul-Terraform-Sync is the concept of a task. So think about task as the glue between Consul and Terraform, where you can essentially say, I want to subscribe to a certain set of services, as highlighted in this example, web and API. And any changes to those services, be it the IP address on which that service instance is running, or the port, or the node on which the service is running, you would have this task being triggered and the underlying automation, which is defined as the Terraform module highlighted in the source, being executed. So in this case, what Consul-Terraform-Sync would do is essentially auto-generate the right set of main.tf, write set of tf vars, as well as populate the variables for those services and manage the entire Terraform workflow of apply and plan as well. So this is something very powerful. It helps simplify that publisher, subscriber, and that automation workflow for you. So we spoke about some core constructs, but it's also important to know that as an operator, when you're running this sort of a workflow and automation tool, you want to know what's going on with the underlying tasks that I execute through this particular tool. So we've also added operational capabilities that provide you visibility into task runs, into per task events, and overall status of all the tasks that are across Consul-Terraform-Sync. And with this Consul-Terraform-Sync, essentially, you can have not just one task, but multiple tasks. So you can say, hey, I want to subscribe to Services Web, and based on that, I want to trigger a workflow, a task for my Panos-based next generation firewall, as well as I want to trigger a task for my big IP. So you can create those separate tasks. You can add multiple services within it, multiple providers within it. So it's a very scalable approach. Again, security is an important aspect when you are dealing with infrastructure, as well as the credentials that are used for this infrastructure components. So we also, from day zero, like right from the beginning, we
Give us one sec, folks. I think we lost audio for Devarshi. Okay. We'll take 1 second. Wait till we get Devarshi back on. Looks like he got disconnected. So just want to say thank you. Like, I know one of the things we're going to cover is on some of the additional integrations, but we want to give a thank you to some of our partners for this launch. We worked very closely with A10, AWS, Checkpoint, Cisco, F5, NS1, and Palo Alto to work on this. So this is really, really exciting, and we are looking forward to more modules being created. But at this point, I'm going to turn it actually over to Daniele to go through his presentation to talk about Workday. And so, Daniele, all yours.
Hey there. Hey, thanks for having me. So yeah, my name is Daniele Bazzola, and I'm a principal infrastructure engineer at Workday. And I work in the infrastructure team, which takes care of a number of things in Workday. The infrastructure takes care of running basic services for the rest of the service teams. So we get LDAP, DNS, SMTP, all that kind of low-level services. We make sure that the basic building blocks are available for other service teams to build on top. So we run and maintain the bare metal servers and the virtualization system on top of that. And together with the rest of the service team in Workday, we run the business, make sure that the Workday application is available to our customers and to our customer integrations. The most, I guess, interesting part of our job is plumbing. We look after the network and connecting all the different services and applications and data centers that we have in Workday. That's probably the most challenging part, I guess, because of the way our network is constructed. We run the Workday application on our own data centers across the world. And we run also workload on public clouds for different reasons. And we have a bunch of dynamic networks. There are new products that are going to be added to the Workday suite and acquisitions from other companies. And the problem there is that we need to make sure that all those networks, they are able to communicate with each other, and we want to make sure that different applications, they can reach different places across our data centers. The challenge with that is that all the different pipes, they just don't fit with each other. In our data center, of course, we build them, so we can use whatever technology we feel like is the better. But when we move to public cloud, we need to rely on what the public cloud provider is offering. And at the same time, getting that to communicate with the data center is not easy, as there's not a single technology that works across the board. And when we get those dynamic networks, we don't know what's there. They're completely random, and it's not simple to get the applications just to use a different underlying network technology to make sure that they communicate with everything else. Since the problem just cannot be solved on a low level, we try to move up to the stack and see if something between layer 5, layer 7 could help solve our problem. So we started to think about this kind of an ideal pipe that can connect all the different data centers and services and applications. This pipe had to be secure with proper authentication, authorization, and of course encryption. We wanted to use standard technology to lower the effort that the different service team had to put in to actually send traffic to this pipe, so standard TLS, X509. And we wanted to use existing libraries, so they didn't have to make big changes, and the onboarding would be simple enough. And of course, this thing needs to scale. We have thousands of services, hundreds of thousands of endpoints, so we need something that can sustain that and can sustain the growth. Went around trying to find the best tool for that, and that's when we start using Consul as a glue to connect all those networks together. We deployed a federation of Consul data centers and created a Consul Connect mesh with them and put that in between the different networks. Service acting as a client, this needs to be able to initiate standard TLS communications, modern TLS with SNI and PLN. And then we take care of that. We grab those packets, wrap them in mutual TLS SPIFFE, send it over using Consul Connect mesh. And then when we reach the other side of the destination network, we unwrap and then act as a standard client before reaching the destination service. Our pipe in the middle is invisible to the service teams. They don't know what's going on, and that's what we are trying to achieve there. Make sure that there's no difference. It doesn't matter what your destination service is. As long as you send the traffic through the pipe, we make sure that those packets reach the destination as fast as possible and still being secure and properly controlled using SPIFFE and MTLS. The ingress and egress from this pipe are where most of the work is done. On the ingress, we have this custom service that we created. We have a front end that is presented to the client that implements the Workday internal standards for our certification authority, our naming convention, and everything else. When the connection comes in, the incoming traffic is inspected and wrapped in a mutual TLS packet that is sent through the mesh using Consul. The backend part takes care of that and checks using Consul intention that the traffic is actually allowed by our policies. On the other side, when the traffic reaches the destination, just before reaching the destination, we do the opposite. So we unwrap the mutual TLS and SPIFFE traffic coming from Consul, take out the payload, and then act as a client and reestablish the Workday internal TLS. So the destination service doesn't see that that the traffic is going through the mesh and just looks like a standard client connection. Of course, those two components, they're quite complex. To deploy or configure one of them, we need to interact with Vault, Consul. We create internal load balancers, security groups, and other firewall rules. So in the beginning, we wrapped everything in using Terraform, and we created a Terraform module that takes care of most of the work. The complexity is hidden behind the module, and the idea was we can control all those resources using Terraform, so it's easy and can be shared across the organization, so other service teams, they can just use our code to add or remove resources from this mesh. The problem with this started actually just after the first service team started using it. So the flow was still ticket-based. We had a team that needed an ingress to the mesh, so they would open a ticket with us or send a pull request in our repository, depending on how confident they were with the code. We get the code review, we got security to approve, and then we deploy with Terraform and notify the team back that the resources are available. And when they're done, something's been decommissioned or there are changes, of course, that's the same. We get another ticket, another review. We need to coordinate with the team, make sure that we don't remove the resources too soon if they're still using them, depending on their deployment schedule and everything. And then we close the ticket. This was better than having to manually configure a lot of devices across the network, but still not good enough. It's not a real automation, it's like ticket-based automation. So there were still a lot of ticketing involved, and my team was still on the hook to make changes. So every time someone needs something, the work needs to be scheduled. We need to add that to a sprint, and depending on different priorities, that will take days. And this was immediately a blocker, as few teams, they wanted to integrate this mesh network with their integration testing. They want to test new software, and they start and destroy them really fast because it's a dev environment. And there was no way to handle this via a ticket. It's just too much churn. And we started thinking, okay, we need to get ourselves out of the picture and make sure that the service team, they can just get their resources without waiting for us to act. And that's where we decided to replace ourselves with an API. And the idea was the service team, they get access to our API, and they use that to request ingress to the mesh or egress, or update the rules, or whatever they might need. The problem there that the Terraform code that we wrote was complex, and it was just makes no sense to re-implement that everything in the API. And that's where Consul-Terraform-Sync came to the rescue. So we integrated our API with Consul-Terraform-Sync. The code that was previously manually deployed was moved to a module that could be used as a template by Consul-Terraform-Sync. We hooked that our API and to Consul, and now we have Consul-Terraform-Sync constantly checking with Consul the different services, and when something changes, it just triggers Terraform and takes care of deploying or removing the resources as needed. This enabled the service team to pretty much self-service, and as soon as they are onboarded to our API, so they have a way to authenticate and interact with it, they take care of themselves pretty much. We have an audit log, and we see what is being created, destroyed. The API itself enforces our security policies, so we don't even need to wait for security to approve because we already encoded the policies there. And as soon as a request comes in, it's checked against the policy, and if it is allowed, it just goes in. And we get security involved only for new flows or something that is not already encoded in our policies, which simplifies a lot and gives the security team time back to do their job. So the new flow after this change it looks like this. That's literally that simple. When a team has access to the API, they just use the API with whatever tools they like. This is actually nice because the first team that we use as an early adopter for this service, they actually created a few tools on top of that. They now have a Kubernetes operator that takes care of translating the state of services in Kubernetes to the API. So when they deploy a new service in their Kubernetes cluster, the API is triggered and the network is just configured to allow traffic to or from that service, which is great. The team also created a small CLI just to inspect the status of the API, so the other service team deploying on their platform, they can verify what's going on, and they can do a quick troubleshooting to see if something is not working as expected. And I think today, someone mentioned that we are close to get Chef integration as well. Another service in the company using Chef for their config management. They are creating custom resources to integrate with this as well, which is great. And we also like a simple thing, like let's say, this API integrated with Consul-Terraform-Sync is actually enabling a lot of innovation and speeding up the work that we are doing. My team is not, enslaved to do this ticket 24/7 anymore. Okay, we're working hard on the API now to improve that as we get a lot of feedback from service team as they start using it. But it's definitely a better way to spend our time than just keep doing the same tickets over and over again. And also, we got rid of all those kind of manual mistakes about when deploying wrong resources, as there are no typos anymore, not fat fingering, as the code is templated, generated by Consul-Terraform-Sync. So that's where we are now. We got rid of the old process. Instead of taking days to deploy new resources, now we're talking about minutes. The average time, it's 2-3 minutes, depending on the network load or the environments. And there are no humans involved at all. This system takes care of itself. We monitor it, but apart from that, it just works, which is great. Now, we started using Consul-Terraform-Sync when it was still in tech preview. So it was a bumpy ride, of course, but it's great to see how the thing is improving and it's getting more stable every day. We are using this in production already, so it's really a good quality there. And in the future, probably we're gonna just use that even more and break it down to avoid some issue that we have at the moment with blast radius, since we run just a single Consul-Terraform-Sync process to manage all the ingresses in a specific data center. Of course, if there's some problem there, that affects all of them. So we're trying to reduce that. And that's actually relatively easy, as Consul-Terraform-Sync is a single binary as usual, so it doesn't take that much to run it, apart from having a proper configuration. The rest is taken care of. And that's it.
Thanks, Daniele. It's great. Okay. Sorry, had a little bit of echo there. Should be good. Cool. Thanks, Daniele. Really appreciate that. It's great to see the insight that you all are getting. One of the things that I wanted to point out in here that I think Daniele mentioned is Consul-Terraform-Sync is very flexible, and you can write your own modules for this. We have a number of predefined modules that are available in the registry now. If you look up NIA, you'll see a number of them, and we're going to go do a quick demo here where I'll show you a couple of those in action, where we're going to show the Palo Alto networks working as well as F5 Big IP. So as we're going through the demo, feel free to keep dropping in questions. We'll answer them towards the end. So give me 1 second just to pull out my screen here. Okay, And if one of, excellent, looks like we are sharing. So cool. I apologize for the size on this. This is a pre-recorded demo. It does take a little bit of time for us to be able to run through the demonstration, so we just recorded it to save ourselves a little bit of time. We will be making this recording available, so you'll be able to see it, as well as being able to try it. So, okay. So what we have here is essentially I'm in a terminal window where I am going to be installing Consul-Terraform-Sync to run with my application. So I'm running a Terraform plan, and essentially what I'm doing is I'm going to deploy a VM that will contain the Consul-Terraform-Sync binary and be able to integrate. And I have some pre-configured things set in place. One of the things I want to show is this is the Palo Alto Networks dashboard. We have a traffic policy in place that basically says that we can allow traffic from big IP to an address group. So that dynamic address group is what we're going to be updating with Consul-Terraform-Sync. If I go into the objects side here, as you can see, that's my dynamic address group. But if I open up the addresses, I don't actually have anything registered right now. So I'll close out here, and then same thing if I go over to the F5 dashboard, there's nothing on my member pool that is currently registered. So we go back to the terminal here. I have an application that is getting a bad gateway connection because nothing is running currently. We'll go ahead and just open up this window. And so now what I'm going to do is I'm going to run my Terraform plan. Okay. And the Terraform plan is going to show that we're creating these 3 resources. So again, we're deploying the machine, and yeah. So right now it's just doing some loading, so it's just taking a little bit of time. So if it looks like things aren't moving, it's just because we're just going through and running a Terraform plan. So not a lot of exciting things happening. Okay, I'm getting a lot. Oh man, hold on. Seems like there's a problem with the video. Give me one moment. I'm going to try and restart it here and see if this will go. So while we were waiting on this, Devarshi, if you're back, we had a question come in just asking about if the solution was specifically targeting network configurations for microservices. Can you dive a little bit into that? Because I know CTS does a little bit more than just that.
Sure. So I think that's a very great question. And I think it comes from the sense that there's some confusion whether Consul works on traditional on-prem environments or does it work with microservices and Kubernetes. Consul actually works across all those platforms. And with CTS, what we've done is you can make CTS work with services and networking that's related to microservices. For example, if you're deploying your services and Consul agents on Kubernetes, you could use CTS to provision ingress gateways and other networking constructs which are specific to that, as well as for not like traditional on-prem environments where we are deploying Consul and CTS as a highly available VM on VM-based or bare metal workloads. You can use the same solution to automate your traditional networking infrastructure as well. So there is no limitation per se that the solution would work with only microservice-based networking solutions. Hopefully that answers the question.
Thanks, Marshy. All right, we're gonna try take 2 on seeing if I can get the demo to play. So give me 1 second here. We'll go to the next. I'm gonna go over the new Consul-Terraform-Sync feature. Gonna show how this works and how it helps organizations achieve network infrastructure automation. What this tool is able to do for users is automate a lot of networking processes that they previously were having to do manually. So network operators were essentially getting tickets to have to update like member pools or various other systems. To show this demo, I'm going to be using our Instruct environment. This was built by our Consul GTM team. So if you would like to walk through this with the customer, feel free to reach out to them, and they should be able to help. So a couple different things that I want to show before we dive into it. What I have in my environment here is I'm in this terminal window. I'm going to be launching a Terraform plan. This plan is going to launch a couple new resources. Basically, what it's going to do is deploy a new virtual machine with Consul-Terraform-Sync and install it. I have, in a previous step, I provisioned a Palo Alto network firewall. One of the cool things here is that if you look, we have a policy set up that's saying to allow traffic from a big IP to my application. That shows this web address where it says CTS address group. But if I go into my objects here, you'll notice while I have this dynamic address group set up, I don't actually have anything in it. So when I open this up, I don't have any addresses. So no traffic is flowing through the firewall right now. Same thing on the big IP side. There's no members in here. So if I look at my network map, I have no objects that are in this partition. And so when I go back to my application, you're going to see I have a bad gateway. So I have no information here. Nothing is flowing. Things are not working properly. And so we're going to fix this with Consul-Terraform-Sync. And then we're going to scale it up and down, just show kind of what happens. So the first thing I need to do is I need to run my Terraform plan. This is going to show me what I'm building. Like I said, I'm adding a few resources, but essentially what I'm doing is I'm deploying somewhere that Consul-Terraform-Sync needs to reside. So Consul-Terraform-Sync is a daemon that sits inside of virtual machine in this instance. It uses Consul service catalog. So I have Consul running right now. And what this is anytime I make changes to those or I make updates to it, Consul-Terraform-Sync is then going to invoke Terraform, and it's going to run the providers. And I'll show you the code here in just a bit. So we know what's going to happen here. So I'm going to just go ahead and do my apply. Okay, so this is refreshing my state. While this is going, let me show you just, again, we know we have the bad gateway here, but just so you can show you that there is an actual application. This is my Consul instance. So if you look at my Consul environment, this one particularly is actually in HCS because this is all running in Azure. I have my Consul servers running. I have a couple instances of my application and my web. If you look at our general map here, what we're showing, so this is the HCS environment where my applications are registered. This is the management piece of it, so where Consul-Terraform-Sync is going to be residing. And then I have my F5 big IP as well as my Palo Alto networks. And so what's happening here is that none of this is communicating with each other because it hasn't been approved to run through these various environments. I also have Vault in here, which is handling some of my dynamic credentialing. Okay, so my apply has completed. And now what we'll see is, again, nothing's changed in the console side. I still have my web. But now you can see I have my service main. This is adding in one of my web pools. So I have these two new addresses that have been added to my web pool. And now if I open up my Palo Alto, you see those same addresses have been added as registered IPs. So now let's go back into our application. We're going to refresh this. And as you can see, I now have connectivity going through these applications. So this is really like a very simple demo, but at the same time, like you can understand the power of this. So now what we're going to do is I'm going to show you what this environment actually looks like and what the code was that we actually ran. So because this is kind of a lot of magically happening right now. So now that I'm in here, I'm going to show you my file. And what's great about Consul-Terraform-Sync is that I can actually code this in HCL. So if you're familiar with Terraform and you've been doing this before, this should be fairly easy for you to be able to run. So here is my config file that I loaded as a part of this. This was part of a Terraform script that I ran earlier, but this would be something that you would customize as part of the install process. What I've done is I told them where Consul is located, so I'm just running it locally within my environment and providing a token so that it can so that Consul-Terraform-Sync can authenticate to it. I have my Terraform driver block, and so this is kind of the power of the engine that is running Consul-Terraform-Sync. So I'm calling Terraform, I'm giving it a path to let them know where it's going, where my working directory is, which is my Terraform code, and then I've indicated my required providers here. So I'm using the big IP provider from F5, I'm using the Palo Alto Networks provider from Palo Alto, and now we're going to get into the actual configuration portion. So as part of my infrastructure options, what I'm doing is I'm passing in my variables that I've dynamically created with Vault. I have my load balancer task, and I have my firewall operations task. And so what these are doing is I've given this a name, and I'm basically saying that every time I find a service named web, what I want you to do is I want you to run this task. And this source is actually coming from the Terraform registry. So this is just a module that's executing when Consul registers a new instance of web. Same thing with the firewall. I have, again, when a new service of web it gets added, I want to use the Palo Alto Network provider to run this module to add it to my dynamic address group. And so these are all happening. It's calling directly from the registry, and these are things that I could use today. The nice thing about this is I could actually use custom modules if I wanted to create my own operations depending on it. The next thing we're going to do is take a look at just like the status. So one of the cool things is not only can I have this automatically execute what I'm looking for, I can actually look at the status of my services. So what I can see here is I can see that it created this, that it recognized that I had this web service, it created and it ran this task. So it completed it, again, it retrieved the API keys for the dynamic address group, and it added everything on there. So this is pretty great if I'm just looking for a log of what is going on. It shows where I had my different resources added, but this is going to be great if I am trusting this with automation to have some sort of visibility into what's going on. So now the next step that we're going to do is we're going to show what happens when I try to scale up or down. Okay, so now we're back in here. Again, we have our application running. Everything's talking to each other. All my web addresses have been added. This is great. I ran it for a one-time thing, but what happens when I want to be able to scale up or scale down? Well, the cool thing about Consul-Terraform-Sync is that it's all automated. So Consul-Terraform-Sync is going to allow me to, whenever I make a change to the Consul catalog, to apply those changes as part of those tasks that I showed you previously. So in this, we're going to do a new apply. We're going to actually increase our app count, and we're going to increase our web count to 2. As you notice on the Consul side right now, I have 2 instances that are running on each of these. So when I run this, I'm going to go ahead and just auto-approve it. Okay, so my Terraform changes have been applied. You'll notice nothing new is added. I just changed 3 resources because they already existed. If I go back into my Consul app now, you see these are just going to show some negative health checks because everything's just getting up and registered with Consul. But you'll notice that I have 3 instances here versus the 2 instances that I had previously. We'll go back into our Palo Alto network device here. We'll refresh our service group. Now you notice I have 3 IP addresses as opposed to just the 2 that I had previously. We go back into my network map. I now have those 3 addresses. So you can imagine what happens if I try to scale up or scale down in this. And there's really the power that you can unlock with this. I've automated my firewall policies, adding different address groups. I've updated my load balancer to receive different information. And again, we are doing this on a smaller scale, but you can imagine what happens when you scale this up. And Consul becomes that real source of truth for being able to keep track of all my services that are running in my environment. I hope this demo is beneficial. I'm going to go ahead and tear things down, and thanks for watching. All right, thanks everybody for bearing with us while we got that squared away. Hopefully that came through all right. I saw some things come into the chat. Excellent. Cool. So that concludes kind of the content portion, but let's get into some of the questions. Let's see. So Devarshi, this might be a question for you. on the input format for Consul-Terraform-Sync, how can you map the inputs from a ticketing system to be the desired format for CTS? Maybe talk a little bit about HCL and kind of how we handle passing in those tasks.
Sure. So I think this is essentially broken down into two questions in one, right? The first question is, what is the format in which you get the variables from Consul or updates from Consul that can be used for downstream automation? And the second part is, how do you integrate with a ticketing system? So I think it's broken down into those two questions. So for the first part, we have a very well-published format on Consul.io in terms of what is the set of variables and the format and the map that is generated by CTS and how you can use it in your automation. What are the different workspaces that have been created by CTS? All of that is pretty well documented, and you could start from there as a starting point to build your own module and automation. And in terms of integrating with existing ticketing systems, right? If you look at the objective of Consul-Terraform-Sync, it is to minimize the number of tickets that are there. But if you have a pool of workflows, in the upcoming releases, we are working to integrate with different technology platforms to enable that approved workflow if you have those requirements.
Thanks, Devarshi. And one thing that my good counterpart Nathan made sure to drop in here: we do not have to store credentials in a CTS configuration file. Ideally, you'd be using something like Vault to store them more safely. That was just for a demo environment, so not a good recommendation for hard coding any of your credentials in there. That was a good point on his part to mention. Devarshi, this one also came in, and I think would be really helpful to kind of dive into. Can you kind of clarify a little bit more of what functions are being leveraged from Consul and CTS? So in particular, like if you're not using microservices, where might CTS be beneficial?
So in case of CTS right now, if you look at Consul, right, Consul has different sets of capabilities it provides through its catalog, right? First is you have the ability to have the set of healthy services from Consul catalog, so we are leveraging that. Consul also has capabilities around KV triggers as well as ingress APIs and other such capabilities. But right now we are focused on services that are present in the catalog and essentially using them to drive the downstream automation. So going deeper into your question, in case of non-microservice-based environments, when Consul is deployed on traditional sort of workloads and monolithic applications and environments, right? You can basically use the health check functionality in Consul and essentially subscribe to services in CTS using that function. So it doesn't necessarily have to be limited to Kubernetes-based deployments. It doesn't necessarily have to be limited to, hey, I want to just provision an API ingress, but it could be used for other functions as well, right? For example, I want to update my ALVs based on the services that are there in Consul. That could be used as well as an example.
Thanks, Devarshi. While we're waiting for some other questions to come in, Daniele, I wanted to ask you, what were some of the biggest learnings that you had in kind of adopting this process, and maybe what were some of the biggest challenges that you had to overcome in order to get it working in your production environment?
Probably in the beginning, we had to figure out the best way to run Consul-Terraform-Sync. We wanted to put that in a place where it could interact with the rest of the infrastructure. And it just took some time to find the right balance there, mostly because, the tool was still young and we weren't sure really how to connect that to the different pieces and different API that we needed internally. But thankfully, since it's just Terraform underneath, we found the right spot there in the network, and we took care of all the rough edges with Terraform. We have our custom modules that run against our internal APIs. And that solved pretty much most of the problem that we had. The nice thing in there that, yeah, as soon as we were able to model our network with Terraform, then plugging that in Consul-Terraform-Sync was kind of easy. The syntax itself, yeah, is the ACL, so it didn't take that much to figure out how to get our stuff to run. So yeah, that was actually nice. I would say probably at the beginning it was hard to get some feedback from Consul-Terraform-Sync, because when we started using it, the status API wasn't there. So that it took a bit of hacking to have some monitoring and stuff in place. But now those problems are gone, so definitely it's going to be easier to deploy more of them and monitor them.
Thanks, Daniele. Just as a reminder, folks, we did record this session. We will make sure to post it to our site, usually within a couple of days. It'll contain all the slides and everything that we went through, as well as the demo video that we covered on here. All right, let's see if we got any other questions coming in. All right. Well, it looks like we covered everything. So once again, just want to thank everybody for taking the time today. I apologize for some of the technical hiccups that we had. Hopefully this was informative. We're very excited about Consul-Terraform-Sync now being available in GA. You'll be able to download it from our site. If you go to consul.io, you can look up the docs. We also have some new Learn materials to help folks be able to get started with it. And if you want to try it in your own environment. I want to have a huge thank you to Daniele for joining us today. Super impactful to see what's happening in the Workday world and how you all are automating these processes. So very excited, and I want to thank everybody for their time today, and have a great day. Thank you all.